And out of this Bravais lattice, 7 are primitive and the other 7 are non-primitive. Okay, so the primitive one is very simple. You can see it's code with P, 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 R, P, P, P. So 1, 2, 3, 4, 5, 6, 7. 7 primitive. And the non-primitive, some are body-centered. 1, 2, 3, 3 body-centered. Out of 7 non-primitive lah, non-primitive. 7 are body-centered. 3 are body-centered. 2 are face-centered. The other 2 are sea-base centered. Okay, so in short, there are 14 Bravais lattice, 7 primitive, 7 non-primitive. Out of 7 non-primitive, 3 are body-centered, 2 are face-centered, and 2 are sea-based. Okay, you don't have to memorize this table. This table shows you 230 spectral growths. Remember just now I mentioned that for the lattice, there is only 230 type of the lattices. Okay, so these are the 230 type of the lattices. So we have 7 crystal systems. The system here: triclinic, monoclinic, orthorhombic, tetragonal, trigonal, hexagonal, and cubic. And we have 14 Bravais lattice. Okay, 14 Bravais lattice. And then we have 32 point groups. And then 230 spectral groups. 230 of the different lattices. Okay, you may very confused of what that all this symbol means. Okay, for this one, you can see that the first symbol always represent the lattice type. P means primitive. Then we have I. I means body centered. F. F means face centered. And then we also have A, B, C. This is like C. We have A, where's A? A. We have A and B and C. So A, B, C represents C base centered. If C is C base centered lah, if B is B base centered, A is A base centered. Okay, I will explain later on in symmetry. So after the first symbol, it's followed by some only have 1, some have 3. Okay, this one 2, this one 2, 2, 2, 1. This one is bar 4, C2. All these are the symmetry operation. Okay. At this moment, you may don't know what is the meaning of 2, what is the meaning of C, what is the meaning of 2, 1, what is the meaning of bar 4. But don't worry, next chapter I will explain what is this 2 means, what is this 2, 1 means, what is this bar 4 means. Okay, these are all the symmetry operation. Like 2, 2 means 2, 4, 2, 1, 2 subtract 1 means sclerosis. This one means roto inversion of 4. Okay, then later on you will study what does all this symmetry means. Okay, so this is a short test, not short test but short quiz. What is the total lattice points in the primitive cell in two-dimensional cell? For the primitive, 1, BCC, 2, FCC, 3, right? And then in 3D, primitive, 1, BCC, 2, face-centered cubic FCC, 4. Okay, 2D and 3D may have different number of total lattice pointers. So there's another way to determine the primitive cell and the cell obtained. We call it a Wigner-Zeit cell. So how to draw the Wigner-Zeit cell? These are the procedure. First, you need to join all the lattice point to its neighbor using a straight line. Secondly, at the middle point and normal to this line, you have to draw a new line or new plane in 3D. Next, the area 2D, volume 3D enclosed by this new line 2D, plane 3D is the Wigner-Zeit cell, Wigner-Zeit primitive cell. So the construction of the Wigner-Zeit cell in the reciprocal lattice delivered the first Brillouin zone is important in the for the energy band structure and diffraction. Okay, this is how we draw it. But before that, I want to explain what this slide means. Okay. There are many ways to draw the primitive cell, right? Just like I have shown. Okay, we have many choices. We have many choices to draw the Wigner-Zeit cell, but there's one unique way that you can draw the the primitive cell, and we call it Wigner-Zeit cell. Okay, the unique way is that we have to go through the procedure 1, procedure 2. After you go through the procedure 1, procedure 2, then you will get a unique primitive cell. Okay, there's only one. There's no other option because you have to follow all this way. Then after I show, then you understand. Then after you draw the Wigner-Zeit cell, so if you draw on 2D model, then you will get the area. Then if you draw in the 3D, which is not possible, but if you're able to imagine, then the Wigner-Zeit cell will be the Wigner-Zeit cell will contain the volume. 3D volume, 2D area. Okay, right. So, but in this subject, I will only show you 2D lah, because it is very, very difficult for me to draw in 3D because I'm not from the art stream. Okay, so I will only show you 2D. So why the construction of the Wigner-Zeit cell is important? Because when you construct the Wigner-Zeit cell in the real lattice, then you get a Wigner-Zeit cell. But if you use the same method to construct it in the reciprocal lattice, then you will get the Brillouin zone. And this Brillouin zone is very important in the energy band structure. Okay, I think there are many information here. I think there are many information in this statement. First, reciprocal. Second, Brillouin zone. Third, diffraction. Fourth, band structure. Okay, so in chapter 6 or chapter 7, I can remember, we study the real and reciprocal lattice. Reciprocal lattice means that the lattice that has been reciprocal, 双上. So if the real life is 1 cm, then reciprocal will be 1 over 1 cm. The real life is 2 cm, then the reciprocal is 1 over 2 cm. So in the real life, 2 cm is longer than 1 cm. But then when you convert it to reciprocal, then 1 over 1 is larger than 1 over 2. Can you get it? In the real life is 1 larger than 2 cm. So 2 cm is larger than 1 cm. But then reciprocal, it becomes 1 over 1 and 1 over 2. So 1 over 1 is now larger than 1 over 2. So this is